okay, for you. Put it in the search box. If you don't have the account, you first create the account. You click on sign up and create the account. After creating the account, you wait for around 10 minutes. After 10 minutes, you go and press on log in. You log in and get to the dashboard. There you scroll around, you'll be able to see the classes. If you are in senior 3, you click on senior 3. If you are in senior 6, you click on senior 6. You'll be able to access all our work there. Also, you can visit our top television Facebook page and be able to get all the videos of the lessons that have been going on. As well as we start, make sure you have a calculator, a pen, a book or a notebook, and invite a friend to attend this lesson. Today's objective, we are going to make sure that by the end of the lesson, we are able to determine the relative molecular mass of a solute in a solution. Okay? So we are going to be looking at determining the relative molecular mass of a solute. In a solution. That is going to be our objective today. Please make sure that you reflect to it with time as we go on with the lesson. So yesterday we looked at a number of things. We had to define what a colligative property is and how it came about. We say that when you mix a solute, when you dissolve a solute in a solvent, you'll be able to form a solution. However, the properties of a solvent changes, and those properties that changes, they are the ones we refer to colligative properties. And we say the colligative property is a physical property which only depends upon the number of non-volatile solute particles, but not the chemical nature of these particles. So we say the properties, we have vapor pressure lowering, we have boiling point elevation of the solution, we have freezing point depression, we have osmosis and osmotic pressure of the solution. And we said these properties can be used to determine the relative molecular mass of a solute. As of yesterday, we looked at vapor pressure lowering of a solute. And on this, we said that it can be also used to determine the relative molecular mass of a solute. And that's what we are going to be looking at today. As well looked at a number of assumptions, we said that the solute should not undergo dissociation or association. We said that the solute should not react with the solvent. Even we said that the solute should be non-volatile. So if we can reflect at all those things, then there is no need for failing to continue. We said that the lowering of the vapor pressure of a solvent is based on Raoult's law. Okay? Raoult's law, we say that is the relative lowering of the vapor pressure of a solvent. Say that the relative lowering of the vapor pressure of a solvent is equal to the mole fraction of the non-volatile solute dissolved in that solution. Okay? At a given temperature. So, having looked at the website, our objective I think now we can go straight to routes law. Okay, we derived routes law yesterday, but to emphasize a few things, we have to go through it again. We said that for you to be able to derive routes law, you should make sure that you consider a solution containing a non-volatile solute. Remember, having a non-volatile solute is very important in determination of the relative molecular mass using the vapor pressure lowering principle. Okay, we said that for us to begin with letting X1 to be the mole fraction of a solute. Okay, X1, let's make this one to be a solvent. Mole fraction of a solvent, X2B, mole fraction of a solute. Okay, so we have the two, X1 and X2. We are letting those ones to be mole fraction of the solvent, mole fraction of a solute. And we said that if this P naught is the vapor pressure of a pure solvent, okay, and P is the vapor pressure of a solvent above is the vapor pressure of a solvent above the solution. Okay, so these are the few things you can use. Then we say that vapor pressure of a solvent above the solution is equal to the vapor pressure of a pure solvent times the mole fraction of the solvent. Okay, vapor pressure of a solvent above the solution is equal to vapor pressure of a pure solvent times the mole fraction of the solvent. Okay, we looked at this one. Then we said that when you add a solvent, when you add a non-volatile solute into this solvent, okay, the vapor pressure will decrease, because remember we are dealing with vapor pressure lowering of a solvent. So immediately you add a non-volatile solute into a solvent, the vapor pressure will decrease. Okay, and we gave a number of reasons. Yesterday we explained how it decreases. We said that it occupies the space above the solvent and decrease the escaping tendency of a solvent. Okay, so we want to see addition of a solute is going to cause a decrease. That means we shall have change in vapor pressure, and this change in vapor pressure will be equal to the vapor pressure of the pure solvent minus the vapor pressure of the solvent above the solution. Okay, that's what we shall be having. So here, if you look at this expression and you compare it with this one, we shall find out that P is equal to P naught X1. So we substitute it. Change in pressure will be equal to P naught minus P naught mole fraction of the solvent. So in mathematics we say that if we have a common term, we do what? We factor it out. We say change in pressure will be equal to vapor pressure of the pure solvent times brackets 1 minus mole fraction. So we get this one, okay? And when we get this one, we call this one our equation 1, okay? We call this one our equation 1. But remember, we are dealing with mole fraction. Mole fraction means there is a given percentage of a solvent and a given percentage of a solute in a solution. In a solution, we expect two things, a solvent and a solute. If a solvent is occupying 70%, that means the remaining percentage is for a solute. So when you get the two, when you add up the two percentages, you'll be able to get 100%. That means x1 plus x2, we get 1. Okay? So what do we get now? We say x2 is equal to 1 minus x1. Okay? Vapor pressure of the solvent, mole fraction of the solvent, plus mole fraction of the solute, we get 1. So mole fraction of the solvent can be got from 1 minus the mole fraction of the solvent. So when we get this one, we realize that in our equation 1, we have it there. So we can substitute. So substituting in equation 1, we realize that we get the change in pressure will be equal to vapor pressure of the pure solvent times the mole fraction of the solute. From what we have got here, if we have change in pressure equaling to vapor pressure of the pure solvent times the mole fraction of the solute. X2 is the mole fraction of the solute. Okay? So we have this. We can make change in vapor pressure divided by vapor pressure of the pure solvent will equal to x naught. And here we shall say we have got what they call Raoult's law. If you can look at that one, we realize that we have got Raoult's law. Because we said Raoult's law is the relative lowering of the vapor pressure. This is the relative change divided by the vapor pressure of the pure solvent. Okay? This is the relative lowering of the vapor pressure. Okay? Is equal to the mole fraction of the solute in a solution at a given temperature. This is Raoult's law. Now, having got this one, we can play around with it to reach on how we can get the calculations. Because mole fraction, some of you can't find it in our question, okay? So we need to go with that one. We say, but x2, how can we get the mole fraction? Mole fraction means the number of moles of that particle, okay, divided by the total number of moles. So here, if we have the mole fraction of the solute will be equal to the number of moles of the solute divided by total number of moles. And total number of moles will be moles of the solvent plus moles of the solute, since 1 is representing a solvent, okay? So what happens here is that when you add in a solution, you look at a cup of tea. In a cup of tea, you put there 1 spoon of sugar, okay? So the percentage, okay, is not 50-50, okay? You cannot put the half of the half cup of the sugar and then the half of it is the solvent. It can't happen. You not take it. So normally we put there too much, the solvent you find is too much, then the solute is very little. That means even the number of moles of the solute will be very, very small, okay, as compared to the number of moles of the solvent, okay. So in any dilute solution, you state in any dilute solution, you realize that the number of moles of the solvent, of the solute, are much less than number of moles of the solvent, okay? The number of moles of the solute are much less than the number of moles of the solvent, okay? So having stated that one, it means that X2 will be equal to N2 over N1, okay? Are we together there? It means that X2 will be equal to N2 over N1. So what happens here where there is X2, we substitute it. We say now change in pressure divided by vapor pressure of the pure solvent will be equal to N2 over N1. Okay? Here we can put the approximation sign. It is approximately equal to that one. Okay? So after that one, I think this one I have finished using it. Can remove it. Please don't forget to visit the website. That website is having tests, assignments, quizzes. You go there and do them. Don't wait for someone to share with you on WhatsApp or on any other platform, because it is individual work. You log in, you do the assignment, then you submit. Okay? Using your personal account. So we are here. We are saying that we have reached here. We are now on this. Remember, change in the pressure, we have been seeing that is P naught minus P over, now we say P naught equal to N2 over N1. So here you can ask yourself, how do we get the number of moles? Number of moles according to you, or according to your O-level math chemistry, number of moles equal to mass over relative formula mass, okay? Mass over relative formula mass, or mass over relative molecular mass, okay? So if we have N2, it will be mass of the solute divided by relative molecular mass of the solute, okay? Then N1 will be mass of the solvent divided by relative molecular mass of the solvent. I would request for slide number 22. So number of moles, we say mass divided by relative molecular mass of that substance. So if you can look at what is above up, is if M1, just there we want to let, if M1 is the mass of the solvent of relative molecular mass M1, this one is M1 small letter is the mass, M1 capital is the relative molecular mass. Then M2 small letter is the mass of the solute. Then M2 capital is the mass of the solute, the relative molecular mass of the solute. So here we say now P naught minus P divided by P naught we shall be able to get M2 over capital M2 divided by N1 is M1 over capital M1. You know, in mathematics where there is division, if we change and put the multiplication, the denominator will become the numerator. So here we shall say P naught minus P over P naught equal to M2 over capital M2 times capital M1 over small m1. So once we get this one, we shall reach, bring back the slide, we shall reach to what they call the formula that can help us in our calculations, okay? We shall get P naught minus P over P naught equaling to mass of the solute on our slides, mass of the solute multiplied by relative molecular mass of a solvent, okay? Mass of the solute times relative molecular mass of the solvent divided by relative molecular mass of the solute multiplied by the mass of the solvent. So all this what we have been doing now has been derived. We have been deriving this. So we can write this above and we go into examples, okay? Let us put this one up here because we are going to be referring to it. Mass of a solute multiplied by relative molecular mass, this one, of a solvent divided by relative molecular mass of a solute times the mass of a solvent. Okay? Mass of a solute times relative molecular mass of a solvent divided by relative molecular mass of a solute times mass of a solvent. That's what we have been looking for. I've got it. If you want to master this, please practice it. Not once, not twice, but at least every day pass through this work. You'll be able to master it. What is important is reaching the step of Raoult's law. Then the rest you can be able to get them. Now we are here. Let us look at our very first example on our next slide. Calculate the expected vapor pressure at 25 degrees Celsius for a solution prepared by dissolving 158 grams of a common table sugar, sucrose of molar mass 342.3 grams in 643.5 cubic centimeter of water at 25 degrees Celsius. Density of water is 0.9971 gram per centimeter. Vapor pressure of water is that one. You can look at the question. That is the question. Inside the question you see that there is what the table sugar is the solute. That means you have been given the mass of a solute as 158 grams. We have been given the density of water and the volume. That means once you are given density and volume, you'll be able to get the mass. Then the 342.3 grams, that is the molar mass of a solute. Okay, so what is the question asking us to do? The question is want us to calculate the expected vapor pressure. Expected vapor pressure. That means you are going to calculate the vapor pressure of the solution. When you go to our next slide, you see all that work being picked out. All what have been given being picked out and summarized. We can see vapor pressure of pure water. They have given it to us as 23 Pascal. Molar mass of the solute, they have given it to us. That is the relative molecular mass of the solute. Then the mass of the solute is 158 grams. The relative molecular mass of water, okay, everyone knows it. Water is H2O. That means sometime back we are calculating the relative molecular mass. Just get 2 hydrogen atoms plus 1 oxygen atom, 16 plus 2. You get 18 grams. Then mass of water. We all know that from our O level. They used to say density is equal to mass of volume. So if you have density and you have volume, so you'll be able to make mass be the subject of the formula. You say mass of water is equal to density times the volume. Okay? Then you'll be able to get mass of water. You get the density which is there in the question and the volume. Then you get the mass as 641.63385 grams. Once you have all that, okay? Once you have all that, then you look back to our formula. The question is saying calculate the vapor pressure of the solution. Okay, so we are going to calculate for P. This one is the one they want us to calculate. Okay, so what do? We first make this formula be with the change in pressure over P naught, because we said P naught minus P is change in pressure, will be equal to mass of a solute. We said it is M2 small times relative molecular mass of a solvent, which is capital M1, divided by relative molecular mass of the solvent, of the solute, times mass of the solvent. Okay, so M2, this one we don't have it, so we shall say that divided by P naught. We have been given P naught as 23. Okay, P naught has been given as 23.7. Let us check in the question. The vapor pressure of water is 23.76. Okay, 23.76 will be equal to, you keep substituting, mass of the solute. Mass of the solute has been given as 158 times the relative molecular mass of the solvent. We have also seen it as 18, divided by relative molecular mass of the solute, which has been given as 342.3. Then times mass of the solvent. Mass of the solvent, we have just calculated it as 641.63385. Okay, that's it. So what do we do here? Yeah, according to mathematics, if you have something here down, you multiply it both sides. Okay? And here. That means here it will cancel out. So you get change in pressure as you get this 158 multiplied by 18 times 23.76 divided by 342.3 times 641.63385. Put it into your calculators and you get the answer. Okay? You'll be able to get the right answer. So when you put it into your calculators, you'll be able to get 0.3077 Pascal. Okay? That is the change in pressure. Okay? So once we have the change in pressure, we have the vapor pressure of the pure solvent. So we can get the vapor pressure of the solution. So here we come and say change in pressure will be equal to pressure of the pure solvent minus the vapor pressure of the solution. So here we make this one to be the subject of the formula. This one. P will be equal to vapor pressure of the pure solvent minus change in pressure. Here you play around, you are not going to follow that simple mathematics, but make sure that this one comes this side as a positive sign. So this one goes that side as negative. Okay? Simple mathematics. Remember, we are dealing with A-level chemistry. So here, having got this one, we shall be able to say P is equal to vapor pressure of the pure solvent is 23.76, subtract the change in vapor pressure, which is 0.3077. Okay? This is what we have. So put it into your calculators and you'll be able to get the vapor pressure of the solution will be equal to, put it into your calculators and give us the answer. That is 23.4523. 23.4523. This one is equal to approximately 23.45. Most of you make mistakes and you approximate from the calculator. You say now, please pick the value from the calculator, first write it, then you approximate. Because sometimes the examiner might be interested in this long answer. For you, give the short one. Okay, but if you give it here and you approximate it here to be, okay, remember I told you don't keep answers in your head because the head is not submitted in the after exam. After writing the things on the paper, you submit on the paper and you forget that you have left some answers in your head. If possible, attach it, but it is impossible. So always write everything on the paper. So this is how we can deal with the example given. Remember we said that we can use the colligative property in one way or the other in calculating one thing or the other. So here we have been able to calculate the vapor pressure, but we have also been able to calculate the the change in vapor pressure. This is the decrease in vapor pressure. So if another question comes asking for determine the decrease in vapor pressure, you should stop from here. Okay? But if it is requiring you to determine the vapor pressure of the solution and the formula is this one, now you say, I have this, I have this, I don't have that one. Okay? Here, to do this, I just wanted to simplify, but as well you can start from here. You put this one, you put that one, you put those ones. Then you'll be able to calculate this one. However, it is going to be hectic. So first calculate this, then you'll be able to get that one. Let us go to example 2 on our next slide. Example 2. And we see for it is requiring us to calculate the lowering in the vapor pressure. Okay? It is not going far. For it is requiring us to calculate the lowering in the vapor pressure. On our next slide, okay, it is requiring us to calculate the lowering in vapor pressure at 290 Kelvin. The vapor pressure of water is, the next slide is showing the example. Okay, the vapor pressure of water is 3,160 pascals. Calculate the lowering in the vapor pressure, which results when 6 grams of urea are dissolved in 1,000 grams of water at the same temperature, given that the molecular mass of urea is 100, given the molecular mass of urea is 100, is 60 grams, okay? Not 100. So this one we shall take it off and we maintain our formula. We can go through the question again. At 290 Kelvin, the vapor pressure of water is 3,160 pascal. Calculate the lowering in the vapor pressure, which results when 6 grams of urea are dissolved in 1,000 grams of water at the same temperature, given that the molecular mass of urea is 60. Let us move to our next slide and see how you can summarize that question. What you do in the paper, after reading the question, first highlight all the values which have been given. We see that vapor pressure of pure water has been given as 3,160 pascal. Molecular mass of the solute has been given 60 grams. Mass of the solute 6 grams. Relative molecular mass of water 118 grams. That one we know it. Should just write it. It will not be given in the question sometimes, but make sure that you put the relative molecular mass of the solvent if they have said that it is water. Okay? Mass of the solvent is 1,000 grams. Okay? So what do? We come here and say they have said we determine the lowering in vapor pressure. Okay? Calculate the lowering in vapor pressure. And lowering in vapor pressure is this one. Lowering in vapor pressure is that one. Don't forget that the decrease in vapor pressure equals the vapor pressure of the pure solvent subtracting the vapor pressure of the solvent above the solution or the vapor pressure of the solution. That is the lowering. Okay? So we say is equal to mass of the solvent, of the solute, times molecular mass of the solvent divided by molecular mass of the solute times the mass of the solvent. So here we shall go straight to change in pressure divided by pressure of the pure solvent that has been given as 3,160 equaling to mass of the solute. Mass of the solute we have said is grams times relative molecular mass of the solvent, which is 18 grams, divided by relative molecular mass of the solute. It has been given as 60 grams times the mass of a solvent. Mass of the solvent has also been given as 1000 grams. Okay, so that's where we are. You can see that it is a very simple calculation once you understand the basics. Okay, so what do we do here? We said we multiply this one on both sides. Okay, according to mathematics, and you cancel it out. So we get the change in pressure, change in vapor pressure, as put this one into the calculator and write the correct answer. Okay? Put it into the calculator and be able to write the lowering in vapor pressure, the value in representing the lowering in vapor pressure. When you put it into the calculator, what do you get? Make sure that you get 5.688 Pascal. So that one is going to be our correct answer. So you are seeing that we are using the same principle to calculate for a number of things. We began with the vapor pressure of the solution. Now we are looking at the lowering in vapor pressure or the decrease. Let us look at the third example, that at least you can be able to look at the relative molecular mass of the solute. Okay, so on our example number 3, it is saying the vapor pressure on our example number 3, the vapor pressure of bicarbonate or carbon sulfide at a certain temperature. Producer, give us the example. The vapor pressure of carbon sulfide at a certain temperature is 53,330 Pascal. Okay. Give us the slide. The next example. The vapor pressure of carbon sulfide at a certain temperature. Next example. Example number 3. Yes, the vapor pressure of carbon sulfide at a certain temperature is 53,330 Pascal at the same temperature. A solution of 5 grams of sulfur in 63 cubic centimeter of carbon disulfide has a vapor pressure of 52,340 Pascal. The density of the carbon disulfide at the temperature is, at this temperature, is 1.27 gram per centimeter cubed. Calculate the relative formula mass of sulfur, the molecular formula of sulfur in that one. Okay, so if we go to our next slide, we shall be able to see how we can summarize that question. We said that summarizing the question first is very important and the key, so that you'll be able to get the values to fit into your calculation. Okay, look at that summarized work. You should be able to summarize your all the things which have been given, be able to list them. Vapor pressure of the solvent has been given. I told you that the vapor pressure of the solvent is higher than the vapor pressure of the solution. Okay, so the one way to identify the two in the question, be able to look at the values given. Okay, there you can see that the vapor pressure of the solvent, we have been given a value that is 53,000, 52,000. That means the one which is 53,000 is the vapor pressure of the solvent. The one which is 52,000 is the vapor pressure of the solution. Mass of the solute has been given. Relative molecular mass of the solvent also, it is not given, but a solvent, once a solvent is given, already I've looked at the vapor pressure of the solvent, and the solvent now is carbon disulfide. Remember that you had to put sulfur in carbon disulfide. That means carbon disulfide is our solvent, not water. Okay? So once you have it, mass of the water, mass, you can remove the word water, mass. To get mass, we shall be able to say mass is equal to density times the volume. If you leave alone the word water, mass is equal to density times the volume. So mass will be 1.27 times 63, which is 80.01. Once you have that one, you go straight to the calculation. Remember, I've been given the pressure of vapor pressure, the pressure of the solution, the vapor pressure of the solvent, vapor pressure of the solution. This one is 533 minus 502 52,340 divided by vapor pressure of the pure solvent is 53,330. This one will be equal to mass of the solute. Mass of the solute has been given as 5 times. We have calculated for the mass of the solvent, which is 76, divided by relative molecular mass of a solute. Now in this case we say that relative molecular mass of sulfur, because is the solute, times the mass of a solvent. Mass of a solvent, we have got it as 8.01. Okay, so here what is important is making this one to be the subject of the formula. Okay, you will say relative molecular mass of sulfur. Okay, so you multiply this on both sides and it comes this way. Then this one multiply there, this one divide it there, this one you multiply it there. So you'll be able to get this 5 times 7, 6 times 53,330 divided by 8.01 times bracket 53,330 subtract 52,340. Okay, once you put that one into your calculator accurately, you'll be able to get 255.844 grams. Okay, so we shall say that the relative molecular mass of sulfur is approximately 256 grams. Okay, once you have that one, you'll be able to get to calculate for the next question. Okay, there you may ask how many number of atoms are in this. Okay, so to get the number of atoms, you'll be able to here getting number of atoms. in this will be equal to 256 divided by the mass of one atom. So you'll be able to get 8. So it is SC8. This one is S8. Let us display slide number 32 and we see how S8 can look like. Okay? S8, how it looks like. Slide 32. That one. That's how you can draw the structure of S8. Okay? So let us move to the assignment. Next slide is the assignment. For you to be able to get that assignment, you can visit our website. Okay? Visit our website www.kodaiSchool.ac.ug, or be able to visit the Facebook page of Top Television. You'll be able to get the videos and the directions. Okay? Or you can contact the facilitator on my Facebook page, Saul Abooki. You can contact me on Twitter at Saul Abooki UG, or you call me. Okay? When you go to the Facebook page, the number is there. You can contact me and we shall be able to learn together. Okay? Please, the assignment given, be able to do it, and you can contact me for guidance. You have been good listeners. Thank you. Let us meet tomorrow, 6 a.m. to 7 a.m. A-level chemistry, colligative properties. Thank you.
Television, your family network.